Hi all, today's topic is Poisson distribution derivation. First we'll derive moment generating function for a Poisson distribution and find its mean and variance. So the derivation already this is second derivation. So moment generating function is nothing but MGF. The notation for MGF is mx of t or m of t we can write. It is discrete. Poisson distribution is a discrete. So summation over e to the power tx into p of x. This is for a discrete. Everyone know this formula. Okay. Now p of x is nothing but e to the power. Okay. So we have to write the formula for a Poisson distribution. So the Poisson distribution, the formula is nothing but e to the power minus lambda, lambda power x divided by x factorial, this is okay, x equal to 0, 1, 2, etc. till infinity. This formula I have given in my starting video, formula video in this unit. You can cross check the formulas, then you can come with this. So p of x, it is e to the power minus lambda, lambda power x divided by x factorial, where x is nothing but 0, 1 to infinity. We have to substitute p of x is in this and expand it. You get one short form, that is the moment generating function. That only I am going to do in this. So it is m of t, moment generating function, summation over e to the power tx as it is. P of x I am going to substitute. So e to the power minus lambda, lambda power x divided by x factorial. We know that e to the power minus lambda is a constant. I will take it outside. E to the power minus lambda taken outside. Summation over. You check in this, both are same variable only. The first term and the last term are same. I can write it as e to the power t into lambda the whole power x. Okay, I can make it two term, combine it as a single term divided by x factorial. Now put x equal to 0, 1, 2, etc. till infinity. I have to extend it. Okay. So e to the power minus lambda as it is. Put x equal to 0. Anything power 0. Okay. So e to the power t into lambda the whole power 0 is nothing but 1. 0 factorial is nothing also 1. So the whole term is 1 plus the second term is e to the power t into lambda the whole power 1 divided by 1 factorial plus e to the power t into lambda the whole squared divided by 2 factorial, etc. It goes on. Okay, this you have seen. Where you have seen this formula, you remember or not, I will recall the formula. It's nothing but 1 plus x by 1 factorial plus x squared by 2 factorial plus etc. It's nothing but what it is, the formula. Anyone can remember it. It's nothing but e to the power x. E to the power expansion is, this is the formula. Everyone know that e to the power x is 1 plus x by 1 factorial plus x square by 2 factorial, etc. So now we have the same procedure. Instead of x, I have e to the power t into lambda. Okay, so now when I substitute it, e to the power minus lambda into e to the power t into lambda. Okay, so both are exponential function. Combine it. So when I combine it, e to the power lambda, I will take it outside. So when I take it outside, so lambda when I take it outside, e to the power t minus 1 I can write. So my moment generating function is nothing but e to the power lambda into e to the power t minus 1. This is my moment generating function. Moment generating function we have completed. We have to do mean and variance. Only half part completed. Mean and variance I have to do it. Mean, how can I do it? Means same as my previous video. Refer in the binomial distribution. You can refer in the video so that the same procedure only we have to do it. So it is nothing but mean is e of x is one time differentiation with respect to t moment generating and put t equal to 0, I will get my first moment. E of x squared is two time differentiation of moment generating function and put t equal to 0, I will get my second moment. 3 time differentiation, I will get my third moment, e of x cube. 4 time differentiation, etc. It goes on. So now when I do it, So we'll do differentiate it. Okay, one time differentiation with respect to this. So e of x is nothing but one time differentiation when I do it. E to the power any differentiation, it is as it is. Into inside function I have to differentiate. Lambda as it is constant. E to the power t differentiation is e to the power t. Now put t equal to 0 in this. E to the power 0 is 1. E to the power 0 is 1. 1 minus 1, 0. E to the power 0, 1. So I'll be getting only lambda. E of x I'm getting to be only lambda. So E of x is nothing but mean. Mean we got to be lambda. So completed. Mean is completed. Now E of x squared I have to do it. Same way this one more time. Because E of x squared one time differentiation of my E of x. Okay. So before substitution. Okay. So lambda into e to the power t into e to the power lambda into e to the power t minus 1. Okay. So this I have to do it. Lambda is a constant that I will take it outside. So when I do a differentiation, okay, it is uv. Differentiation now you check. It is uv. This is my u. This is my v. Differentiation of uv is nothing but uv dash plus vu dash. Okay, so when I do it, e to the power t as it is, when I differentiate this, it is e to the power lambda into e to the power t minus 1 into inside function lambda into e to the power t plus e to the power lambda into e to the power t minus 1 as it is. E to the power t when I differentiate e to the power t only, put t equal to 0 in this. So when I put t equal to 0, lambda as it is e to the power 0, 1, e to the power this 1. So lambda only I'll be getting lambda plus in this when I put e to the power 0, 1, 1 minus 1, 0, e to the power 0 again 1, e to the power 0 again 1. So this is my answer. So lambda squared plus lambda I'm getting. E of x squared I'm getting lambda squared plus lambda. So everyone now calculate variance. Variance, the formula is nothing but E of x squared minus E of x the whole square. Okay, so E of x square now we have calculated. This is so lambda squared plus lambda minus E of x the whole square. So lambda squared. So get cancelled. So variance I'm getting to be lambda. Variance I'm getting to be lambda. Mean and variance are same for a Poisson distribution. So completed. Derivation we have completed. So do one simple problem. First problem. To understand the concept of Poisson distribution, problem 1. Six coins are tossed. 6,400 times using Poisson distribution. They particularly mention Poisson distribution. The same problem can be done also using binomial distribution also we can do. So that is the reason they give the distribution. So using Poisson distribution, what is the approximate probability of getting six heads 10 times? This is our question. So if the question is given like this, so how we have to do it means Poisson distribution. So what is the data given? P everyone know. Okay, six heads. Okay, so one toss 6 coins. Okay, 6 coins they told. In a one toss, 6 coins. So P is nothing but the probability of 6 heads. 6 heads. Okay, 6 heads in one toss of 6 coins. Okay, this is the question asked. Okay, so it is meaning when we toss a coin itself, head only. Head means we'll be getting 1 by 2 is the probability, but is it mentioned 6 heads? So it is nothing but 1 by 2 the whole power 6. P is given to be 1 by 2 the whole power 6. N it's given to be 6400 times. N it is given in the question to be 6400 times. Okay. Now NP only given. Lambda it is not given in the question directly. Okay. So, but asked to do using Poisson distribution. They asked to do by Poisson distribution. Binomial means directly we can use in the formula. Poisson distribution, when I convert it into lambda only, I can do it a Poisson distribution. So how can I convert it? Means P know the relation. One relation is there. When N, P are given, I can convert it into lambda. It's nothing but lambda equal to NP for a conversion. So N and P when I multiply it, it is converted to lambda. So N and P multiply it. So 6400 into P. So 1 by 2 the whole power 6 when I multiply it. 2 power 6, 2 power 6, 6. So I'll be getting 6400. So 100. So lambda we got to be 100. Now it is in terms of lambda. Now we can, whatever the question it is asked, the final question, I can complete it. Okay. So first I will write the Poisson distribution formula. P of x is nothing but e to the power minus lambda, lambda power x divided by x factorial. General formula we have to write, then only the corresponding we have to write. X equal to 0, 1, 2, etc. till infinity. Write with the limit. This is called limit. Without this, you write the formula, it is meaningless. Okay. When you write any formula, it may be a binomial distribution or exponential distribution, any distribution, the corresponding limit also you have to write it. Now substitute e to the power minus 100, 100 power x, the whole divided by x factorial. Okay. So this is our now given parameter. So now whatever the question it is asked, we can calculate it. 10 times only they asked. So 10 times it is nothing but x equal to 10. So x equal to 10 we have to do it. So x equal to 10 when I do it, probability of x equal to 10. 10 times only they ask. X is 10. Okay, so 10 I have to substitute instead of x 10. So e to the power minus 100. So 100 power 10 divided by 10 factorial. 10 factorial, do it in a calculator, don't do manually. Okay, so you may do mistake. Everything we have to calculate in a calculator. We have to bring calculator. E to the power minus 100 into 100 power 10 divided by 10 factorial. Calculate in calculator. I'll be getting the answer to be 1.025 into 10 to the power minus 30. So this is my answer. So completed. Thank you.